So what is a DAX? DAX, the abbreviation for DAX is like, so sorry, the DAX stands for data analytics expression. Okay, and using DAX, you can perform advanced analytics in Power BI. A lot of built-in functions that are available as part of DAX, using which you can do advanced analytics, basic to advanced analytics. Okay, so now we'll take a look at what is DAX is all about, and what is the TPAC engine, what are the operators and data types that are available in DAX, and then if possible, we will jump into the aggregation functions, the rounding functions, logical functions in today's session. First thing first, what is a DAX? It is a collection of functions, operators, and constants that can be used in a formula or expression to calculate or return one or more values. Okay, maybe my definition is a very lengthy one. In simple term, it is a combination of functions, built-in functions, operators, constants that you use it in your formula. DAX is not only used in Power BI, it is used in Excel, Power Pivot, and SQL Server Analysis Services, Tabular Edition, and Azure Analyst Service also. And the DAX is used. DAX can only be used to filter or query a physical table. Okay, so those things you need to keep in mind. And we discussed about M language as per a Power Query Editor. There are two types of languages that are supported in Power BI. One is M language. We have seen already as part of the Power BI, Power Query Editor. And the next one is DAX. Okay. And what is M language? M is a query language. It is used in Power Query Editor, whereas DAX is an analytical data calculation language. So these two are mutually exclusive. Okay. They are, these two are completely independent. Okay. M and DAX are not dependent upon each other. You cannot combine these two things together. DAX is separate. M language is separate. Just bear in mind. Okay. And the next one is we will take a look at the DAX engine. Now let us understand the mechanics of how the DAX formula is processed behind the scene by DAX engine. See, the DAX query engine is composed of a formula engine, and you have something that's called storage engine. So these two engines work together to compress and encode the raw data and access your DAX queries. Okay, whatever you read it access that way. Now we will take a look at or we'll explore the role of these two engines, the formula engine, storage engine, what these engines are doing it, okay, behind the scene. The formula engine is responsible for accepting the DAX query. Okay, so you have created a measure. For example, you have created a measure using a DAX formula. Okay, the query. Okay, so what happens is the formula engine behind the scene, it accepts the DAX query, and then it processes the query and then generates something called query plan. Okay, so in the case of import connectivity mode, the formula engine, what it does is it sends a data request to the storage engine, because the formula engine cannot retrieve the data directly from the data set. So upon sending the request to formula, upon sending the request from the formula engine to the storage engine, what storage engine does is, it is the responsible storage engine to return the data back to the formula engine. But in the case of import connectivity mode, the formula engine generates the query plan, and then it sends the query plan to the VertiPack. This is specific to import connectivity mode. Upon receiving the query plan, okay, and what this VertiPack does is it converts your tabular data into columnar database, and then it encodes the data and compresses the data and load it in memory. Since it's an in-memory columnar database, the performance is much faster. Now the question is, what is columnar database? Don't worry, we will discuss it a little later. Okay. So what happens is the query plan will be sent to storage engine. Storage engine's VertiPack engine. So this is some software. Okay, this is a piece of software. And what happens is, upon receiving the query plan, the VertiPack, it converts your tabular data into columnar database first, and then it encodes your data, and then it does the compression of the data, and then load it into memory. Anything, if you compress it and load it into memory, the memory, the consumption of the memory is very less, right? If you compress the data, and if you load the compressed data in memory, it will not consume too much of memory, isn't it? So that is the job is done by Vertipack in the case of import connectivity mode. And then what it does is, whatever, for your query, DAX query, whatever the output is that is required, right? So it goes and do the lookup in that in-memory thing, right? So the columnar database, which got cached in memory, right? So that data will be returned back to your formula engine. Hey, this is the data you are looking for it, take it up. Upon receiving the data back from Vertipack, the query formula engine will return the output to the user, right? So let's say in the DAX query, you want the total sales amount. Hey, give me the total sales amount. Sum of sales amount. You have a function called sum function. Let's take a simple example. Sum of sales amount, you have created a measure. You just, when you drag and drop this into visual, that is your DAX query, right? You are sending a request. Behind the scene, all we do is just in the front end, we just simply drag and drop the measure to the visual. Behind the scene, what happens is the formula engine accepts that request, your query request, the DAX query request, and then it processes your request, the query, and then it generates a plan. And this plan is sent to your Vertipack. Vertipack behind the scene, it does all the things, whatever I said. Okay. In the case of direct query, what happens is, for example, instead of using the CSV file or flat files, we are using the SQL server as a source database. You want to extract the data from the table. So you are sending the query in the measure. Right? What happens, even in this case, it generates the query plan. And then this query plan will be sent directly to the SQL server. And then the query will get executed in the source system SQL server itself. And the output, the result of the query will be sent back to your formula engine from your SQL server directly in the case of direct connection mode. The advantage of the in-memory models, right? The imported and compressed column memory caches in the storage engine. So anything available in memory is pretty faster. You just remember this, okay? The 1 second, I just the import mode only. Does it do the does it convert the table or data into columnar, and then it does the encoding. After doing the encoding, it does the data compression, and then it loads the data in memory. Is that happening only in Vertipack? Yes, it is happening only in this case of Vertipack. In the case of import connectivity mode, okay. And for example, okay, if you work with a direct query, you cannot use the Vertipack storage engine. Okay, the Vertipack storage engine can only be used for imported models using the import function. Please remember this. Okay, this is very important. And now the question is, what is columnar database in the case of Vertipack? Okay, what is columnar database? This is what your columnar is. For example, the data is stored in Excel like this. Okay, and when you the Vertipack, what it does is, instead of by default the data is stored in the row store, it converts this into a column store. In the case of column store, it stores each and every column separately. See what happens in the case of row store. Let's say you want to see the product name and then the unit price. For this specific product, what is the price? You want to see it. In the case of row store, what will happen is, let's say you have 100 columns are there, it will go and check first column, whether it is a name or not. No, it is not name, it is ID, you skip it. And then it will come and check name. Oh, okay, pick up this one. Next, I need a unit price. It goes and checks next column. This is not unit price. Okay, skip it. If you have 1,000 columns or 100 columns, to find out the columns that are of interest to you, let's say you want to select the data only from the 2 columns, but in the data set you have 100 columns are there. So it will go and check each and every column until it finds the column that you are looking for it, right? It keeps skip it. For each and every row it does, it takes a lot of time. That's the reason what they do is they store each and every column separately, so that if you want to see the product name, it will go directly here, and then it will go and do the scan in the price directly, product and price. Only these 2 columns will get selected, and it does the lookup here itself. So for example, camcorder and smartphone unit price only, I just need to know. So in that case, it will go directly to these two columns, and then it retrieve the data. Hence, it saves a lot of time instead of going through each and every column and check whether this is a product name column or not. Is this a unit price column or not? Right? You don't have to do that. That is the advantage of columnar database. So in the case of columnar database, single column access fast and effective. Simply said, the columnar database are more CPU exhaustive, while the row store databases increases IO. You need to go and read the data in the disk, and then because of many scans of useless data, it will slow down the performance. Okay, so now you understood what is columnar database. And next, I told you one more thing here, right? So it does the Vectipack engine, it converts the tabular data to columnar data. Now we understood the advantage of columnar database. Not only it does convert the tabular into columnar, and also it does the encoding. So what is encoding? You have something called a compression encoding. The object of this one is to reduce the amount of memory required to process the query. As part of encoding, it tries to reduce the amount of memory required. Okay. See, compression is the next step. Okay. And then Vectipack stores a compressed storage of the database memory. So before even it compresses the data, it tries to reduce the existing data itself using a technique called encoding. There are three types of encoding. One is value encoding. Next one is dictionary encoding, run length encoding. So when the value encoding is used on integer values, we just remember only this one. Okay, and dictionary encoding is for text data type. This is a number and text. This is used for repeating values. Okay, so in that kind of situation, it will be used. Now let us take a look at how the value encoding is done behind the scene. The value encoding is used on integer values, especially since Vectipack converts a lot of values in Power BI to integers. Okay, so what happens? Let's see, this is what your data. In this data, first it will find out the minimum value. So what is the minimum value here? 194. It subtracts the minimum value from each and every value, and then it gets this value. For example, 194 minus 194 is 0, right? 197 minus 194 is 3. And similarly, it subtracts the minimum value from each and every value, so that what will happen is, here you will end up, you need only 5 bits to store this data, because you have, it reduces the number of bits, right, needed. So by subtracting the minimum value from each and everything, okay. So in this case, so what happens is, it reduces the range of column, right? It reduces it to a range from 0 to 22. Instead of 194 to, what is the maximum value here? 194 to 216, right? Here 0 to 22. It reduces the range from here to here, okay? And in this case, storing numbers up to 22 requires less bits than storing numbers up to 216. So in this case, while 3 bits might seem a very small saving, when you multiply this for a few billion records, it is easy to see that the difference can be an important one. Okay, right? So you might be thinking, okay, this is how, say this is 5 bits only needed to store this value, but here in this case, 8 bits are required. We are saving 3 bits only. Does 3 bits matters? Yes. If you have, nowadays we are dealing with billions of records. So 1 billion into 3 bit, it will go like anything, right? So in that kind of situation, yes, you are reducing the space required to store the integer value. On top, after reducing the size, right, you are doing the compression. When you do the compression, once again your data size will get reduced, and that compressed data get loaded in memory. The performance will be very, very faster. Got it? See how they have done it, right? Beautifully, right? The next one is the hash encoding. As I told you, hash encoding technique is used on text values. So the behind the scenes, the Vectipack engine builds a dictionary containing the distinct values of the column. For example, I have a column called color, and here all the colors are repeated, right? So it builds a dictionary something like this. Okay, what happens is, so the second step, what it does is, with this given data, it creates a dictionary like this. So it assigns a 0 for red and white for 1. It takes only the unique values. So black only one time, blue only one time, though it appears multiple times. So all we need is how many colors are available in total, only 4, right? Each color it assigns some value, 0, 1, 2, 3. And instead of red, red, white, white, so whatever this dictionary value ID got assigned for each color, right? That one will be assigned. So for example, in the place of red, 0 will be assigned. In the case of white, white 1 will be assigned. Look here in this case, the space will be very, very less to store. So whenever you want to know, okay, what is 1? Goes and do a lookup here. 1 is nothing but white. Keep a dictionary file separately, right? So, and then whatever the value, IDs assigned for each color, that you can replace it. That value you can use it to replace the text values, so that your color column will have, the color ID column will have less values, right? On top, if you do the compression, the space will be very, very less to utilize the memory utilization, right, for the thing, right? Not only memory, even the data, whatever you store it and read it and load it in memory, right? It will consume less space in the memory, and on top, if you compress it, it will be much faster. Next one is the run length encoding. It is used to look for repeating values. For example, in a column called quarter and Q1, 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 it appears 310 times, and Q2, these values are appearing 290 times. Okay, this is pretty straightforward, the run length encoding, because it becomes really powerful when it is combined with another type of encoding. So in this case, what happened? Q1 starts from 1 and then 310 times a count. Okay, and it appears 310 times, and the Q2 starts from after the 300th position, 311, and then how many number of times it repeats? 290 times. And now what they do, they combine the dictionary encoding with the RLB. So dictionary, we know the Q1, Q2, Q3. For this, they assign summary 0, 1, 2, 3. And for the run length encoding, we replace the Q1, Q2, 3 by 0, 1, 2, 3. 0, 1, 2, 3. 0 means Q1. And Q1, we have 310 records are there. And in Q2, 1, right? So 290. So the combination of dictionary as well as the run length encoding, it's an hybrid of these two things. They use it in the case of repeated values. That is called your run length encoding. So using these different techniques, right, they do encoding for different data types so that the storage space is less storage space is required. Obviously, when it requires less storage space, the compression also pretty faster, and the compressed size of the data, that is also very less. Okay, to summarize, DAX uses two engines, the formula engine and storage engine. The formula engine interprets and evaluates DAX, and the storage engine compresses and encodes the data. The interview, they'll ask you this: what is the role of formula engine and storage engine? See, in simple term, formula engine, it cannot directly go and fetch the data. It is relying on the storage engine. Storage is something like only mother has to cook, right? Father will order, hey, give me food. Mother will prepare, something like this is father, this is mother. Okay. Formula engine interprets and evaluates the DAX, and it sends a request to storage engine. Storage engine begins and compresses, encodes the data, and then it sends the data back to your formula engine. There are two types of storage engine. That's what we discussed, Vertipack and direct query. And Vertipack stores the data using a column database data, and the data is stored in this case, data is stored in individual columns that can be accessed quickly. But queries that call multiple columns may require complex logic to produce a data cache, and raw data is compressed and encoded to optimize processing. Data can be compressed using value encoding, hash encoding, or run encoding, and the overall compression of column is determined by 4 factors. You need to know the cardinality. What is cardinality? The unique number of values, distinct values in a column, and then the number of repeated values in the row count and the data type. So based on these factors, only the overall compression technique is determined. Okay. Next, we will take a look at the data types that are available in DAX. Like any other programming language, here also we have some integer, decimal, and currency data types are available. The whole number, it is an integer data type. It can take the integer values anywhere between this and this. A very big number, right? DAX only has one integer data type, so it can store a 64-bit value. All the internal calculations between integer values in DAX also is a 64-bit value only. Remember this, okay? And the next one is the decimal number. In the case of decimal number, also it uses 64-bit real number. It takes the negative numbers anywhere between this range, and positive number, it takes the value anywhere between this number. Okay, and it is the decimal number is always stored as a double precision floating point value. But don't confuse this DAX data type with the decimal and numeric data type of transact SQL query. Okay, the corresponding data type of a DAX decimal number in SQL is float. We call it float data type. Okay, the next one is the currency. The currency data type is also known as the fixed decimal number in Power BI. It shows a fixed decimal number. Okay, and you might be asking this one, then what the hell the difference between these two? Okay, and here it can represent four decimal points, and it is internally stored as a 64-bit integer value, but divided by 10,000. Okay, adding or subtracting currency data types always ignores the decimals beyond the 4 decimal point. You need to remember the date is a pretty straightforward. Under the cover, the date time is stored. It suppose dates from March 1 to 1900 through to December 31. This one only. So if you want to store any date, earlier than this, date, it will not work. Anything after this, if you try to store, it will not work. Okay, the next one is the data types. All right, so we'll continue with this data types. Apart from this, we have something else called text, and the true false is Boolean, and we have something else called blank data type, and we have something called the table data type. It represents table in the data model. Okay, so these are the things, and we will see it how we can use it as we move forward. When I start writing the DAX queries, you will get to know, right? So how we can use these types of data types. And what are the operators that are available? Like other programming language, same thing. You can perform arithmetic operation, and you can do you can use comparison operators, like arithmetic operators plus minus. For example, 3 plus 7 is 10, and the minus, this star is nothing but multiplication. This is division. This is exponentiation. For example, if you want to take 3 to the power 4, so caret symbol needs to be used. And comparison operators. For example, if you want to check the first name, let's say I have a column called first name. In the first name, eon value is there or not. If you want to check it, first name equals sign eon. Okay, so in the first name eon is there, and here also eon. Then it says it's true. Okay, strictly equal to double equal sign. Number equal to true only when number equals 0 and false equal. If 0 is equal to 0. If it is true, let's say in the number column, you have stored a value something as 0. 0 is equal to, it does the comparison. And if it is same value, then it returns true. Otherwise, it returns false. And if something is greater than 100, you need to use greater than sign, less than if you want to compare, right? And greater than or equal to. And next one is the logical operators. Logical operators are, this one, AND operation. For example, I wanted to see the total sales amount in Afghanistan and United States. So in that case, what we do is we calculate sum of sales amount, comma, filter condition use country is equivalent to Afghanistan, and then use double ampersand, and then country equal to United States. Only when these two countries, data is there, you do the give me the total sales amount. I want to see the America and United States and Afghanistan's total sales. In that case, we use ampersand. So we have something called logical OR operator. So if it is USA, true. For example, if the country is equal to America, or country is equivalent to Afghanistan. For example, in my data set, I don't have America data. United States data is not there. But still, it will return. At least in these two conditions, any one of the conditions is true, it will become true. Okay, the country equal to United States, there is no record like United States. In this case, it is false. Okay, and then here Uh, but here, country is equal to Afghanistan is there. And this either of them is true, right? So this is not true. Though it is not true, at least this one is true, hence it will return true. Okay, so that's what I mentioned. True, false, right? It's true. Or false, true, it will be like a true only, right? So, and these are called, so the truth table, something like that. And the next one is in. For example, in a column, if you want to see more than one value to check it, right? In the channel name column, do we sell it in store and whatever the sales we made it in store, online, catalog, in the channel mode, right? So these three different channels, what are the sales we made? We want to select only that one. So in that case, channel name in operator we can use it. This is a logical OR. Okay, it creates a logical OR condition between each value. So that means channel name in store or store channel name in online or catalog. Okay, that is how it will work on this. And the next one is the logical functions. One of the important function switch is available in DAX. It is really, really helpful. If you want to write multiple if conditions with one simple switch condition, you can write it. Okay, you don't have to write multiple if else and all. So this is pretty straightforward. So in this case, the first argument is expression, and rest of them are value one. I'll just show you one example so that you'll be able to understand with that one. Don't worry. And the next one is the concatenation. Okay, and we have something called test con. If you want to concatenate more than one column, right? So we can use ampersand. I just, instead of talking everything, I just go to the data set. Look here, I just click on this data thing here. And then I just go to the customer. Very good. I have something called first name and last name. And for example, I want to combine these two things together programmatically. Okay. What I do is I just create a new column. So you remember the custom column, right? How to create custom column. So here what I do is I just say the first name, the bin customer username, and then I'm going to use ampersand sign here. So ampersand, comma, ampersand. So I need to put this one, double quote, and then last name, sorry. So what will happen is we combine these two columns into a single column. Okay. So this column will have, for example, name. Okay. So this name column will have both the first name and last name. But the first name and last name in between, if you want to give a comma, you can give it. If you just want to give a space, you just give a space in this double quote thing. Okay. I just pressed enter mistakenly. Anyhow, look here. Between John and Joseph, if you want to leave one space, you need to leave one space here. For example, if you don't give any space, and it will not leave any space. Look here. That is the reason why between the ampersand we use double quote, and you can leave. If you want to have double space, you can give double space. One space is more than sufficient. Press enter. This is how you can concatenate the values in a text using ampersand. This is called your ampersand. Ampersand, ampersand. Okay, you can do it that way. Okay, what we will do is it's already 20 to 19, 10, 20. So what we will do is tomorrow we will continue the session. Tomorrow we will try to cover the DAX functions as much as possible, and also we'll show you how to use switch function, all these text functions. So we'll play around with it a little bit, and then we'll jump into the DAX, and we'll try to cover as many DAX functions as possible tomorrow. And if possible, this Wednesday, we will cover majority of the DAX functions. Okay. And then we will say goodbye to Power BI thing. Okay. And also we need one more session for probably we will do it this upcoming Friday, or we will carry forward to the next week. In the next week, what we will do is we will have a direct, whatever the leftover things, right? We will try to cover it. And then we will start, have the interview preparation session next Monday or Tuesday. We'll have interview preparation session, and then we'll cover SQL also. Let me see if I can cover the SQL server in 1 or 2 session. Okay, that's all. We are all set. We will take up your purpose. See, nobody is going to ask you how you move the data in cloud. You can simply tell them we have an administrator. He used to move the data. Cloud and all, we don't have access, sir. We have access only to the Power BI desktop, and that too, the Power BI desktop, they'll give the username and password to access the SQL Azure SQL server, which is available on cloud. So with that, we pull the data and then we do all of it. It all depends on how smartly you are answering it. That's where I am here to help you how to handle the questions in a very smart way. Okay. But even in the case of real time, billing or not, guys, we don't have access to everything. Okay. And we have very, very restricted access. Even in the case of development environment, also we have very, very restricted access. Okay. Simply, for example, if you want to create a row level security, so that we will see next Tuesday, because most of them to be last one is row level security. Though it is not a developer responsibility, it is only the Power BI administrator's responsibility. They are the one responsible in terms of creating the security, creating a user, all the things that is their responsibility. You can smartly tell them, yes, I know the concept and I know how to implement row level security, but we don't have privilege to implement that. Anything when it comes to implementation, it is all taken care by our on-site administrator. Please remember this. Okay. And that's all, yeah. So if you are a smart guy and you can obviously change your, so you are the game changer